Okay, standard 5, polynomial equations. This will be given during the final time slot. I will not take it until then. Everybody has to take this standard on the final. So we have this equation here, y equals negative 2x to the third power plus 7x to the second power plus 3x minus 10. Now, since my highest power is x to the third, and that's higher than a 2, the graph just goes all over the place. So to get it, we pick basically as many input values that's worth my time, and that's usually 3 through negative 3. Okay, now you're like, that's going to take forever. Well, with these calculators, it doesn't have to. So you've got negative 2, make a parentheses where the x is, and you can go with 3. To the third power, you just hit the upside down v to the third, plus 7, parentheses 3, to the second power, plus 3, parentheses 3, no power, minus 10. Okay, so I got 8 as my output to go with 3. Now, all you got to do is hit the up arrow on your compass, and then wherever there's a 3 in parentheses, you just put a 2. That'll go much quicker, okay? I got 8 again. It's okay. Up arrow, now hit 1. Again, there's no pattern to this, really. Okay, I got negative 2. Then you can do the thing with 0, but if you have 0, you just kind of cover up all your x terms, and there's a negative 10 at the end, so that'll be negative 10. Okay, now unfortunately when you do the negatives, you got to reset the calculator and put negative 1. So negative 2, parentheses, negative 1, close it, raise it to the third power, you just hit the upside down v3 to do a third power, plus 7, parentheses, negative 1. Second power, you can hit this key and 2. You can also hit this key here. Plus 3, parentheses, negative 1, minus 10. Okay, so I got negative 4. And now all I need to do is go over the 1s and put a 2. Keep the negative sign, though. 2, 2, 2. And yeah, 28. And then 3. So up and then 3. 3, 3, and 98. Now 98 is kind of far out there compared to the others, so I'm going to just count by 5 so I can hit 28. So 3, 8, so 1, 2, 3 up 5, and then part way. Okay, 2 to 8, so right 2, and then you're in the same place. 1, negative 2, so I go 1, and then negative 2 is there. Just keep in mind you're going by 5s. 0, negative 10. So down 5, 10. Negative 1, negative 4, so left 1, and then down 4. And then negative 2, positive 28. So I go left 2, and then 5, 10, 15, 20, 25. Keep in mind whether it's positive or negative. So I connect all my dots, but now the arrows, okay? We got to get the arrows correct. So I do this arrow first, okay, as x goes into the positives forever, okay? Now, what you do is you circle your first term. Is it negative or positive? It's negative. So this arrow goes down. Now, look at your highest exponent. I'll circle it, the 3. Is that even or odd? Well, that's odd, okay? It's an odd exponent, so the arrows go in opposite directions. If it's an even exponent, they go in the same direction, but when it's odd, the arrows go in opposite directions, okay? So, up, and then there it is. Okay, now simplifying expressions with exponents. Now, if there's no addition or subtraction operations, we want to go with the 3 boxes. Okay, and then I underline the expression. That's my dividing line. I have a base of 7 and a base of y. Now the 2 seconds, 7's to the second, but it's in parentheses, so 2 times 2 is 4. And the y is to the third in parentheses, 3 times 2 is 6. Now we don't have any reason to move these because they're both positive exponents. And then I just need to figure out over here what 7 to the 4th power would be. The y to the 6th power stays the same. So 7 exponent 4, and I get 2,401 times y to the power of 6. Okay, I don't see any addition or subtraction operations, so again, that's going to be my 3 boxes. Okay, now on top of the line, you have a base of 16, a base of A, a base of B. Now on bottom, you got 18, and then I don't write A and B again. Don't repeat the variable twice. So 16's to the 1, but it's not in parentheses, so we just put 1 down, and then 18's to the 1, so I just put 1 down. Now with A, now keep in mind we have 2 base A's. We have to combine the exponents somehow. So I have -3, okay? And then I'm going to use a subtraction sign. And then I've got, because the reason we're using a subtraction is because A is on the bottom. And then -5, okay? You can either punch -3 minus -5 on your calculator. You go plus 5. -3 plus 5 is 2, A to the second. And the B you have 4, and that B is on bottom, so we subtract 7. 4 minus 7 is -3. Okay, now the ones with positive exponents stay in the same place. But that B with the negative has to go into the denominator, and the -3 goes to positive. And then 16 to the first is 16, 18 to the first is 18, times A to the second times B to the third, okay? Now, I will allow you to leave your answer like that. Some teachers would have you reduce 16 over 18 by dividing them by the GCF of 2, so it become 8 over 9. You can do that if you want. It doesn't really matter to me. Okay, and then here's my expression here. So no addition or subtraction signs. So I make my 3 boxes, and I want to put a line in each box because we know things can move around with these. So I underline the expression, and my bases are, numerical bases are 6 and 2. So 6 multiplied by 2, and then I have 2 variables, x and y. I don't have anything in the bottom for now. So 6 is to the 1, and 1 times 2 is 2. 2 is to the 1, 1 times 3 is 3. Now for x's, 3 times 2 is 6, and then the other x is on top, so I add instead of subtract, because I'm on top. 2 times 3 is 6. So 6 plus 6 is 12. X is to the power of 12. And then for y, I have -4, but it has to be multiplied by 2. That's -8. And then here's that's the only y I have. So the 6 to the second and the 2 to the third and the x to the 12th remain in the same place. Now the y moves into the denominator so that its 8 becomes positive. Okay, now 6 to the second is 36, 6 times 6. 2 to the third, 2 times 2 times 2 is 8, and then times x to the 12th, then y to the 8th. Now, the big number bases are on top together, so to simplify it completely, we are going to want to multiply those, not just leave them, because they're on top together. If they're on opposite sides of the dividing line, you can just leave it, but if they're on the same side, you need to take 36 times 8. That's 288. Okay, now the next one, there's a 4 right there that got cut off the thing. Now you got to make your boxes a little smaller. I didn't give you a lot of room because I put another problem right there. Okay, so my bases on top of my line are 4 and 3. And then A and B. Okay. Bottom, I just have more A's and B's. So 4 is to the 1, not in parentheses, so it's to the 1. 3 is to the 1. A, we have 3 A's. First A is to the third power. And then my next A is still on top, so we add 2. And then my next A is on bottom, so I'm going to subtract there with 2. 3 plus 2 is 5, minus 2 is 3, so A is to the third power. And then B, we have a -2. And now the next b is on bottom, so I subtract 3. And then the next b is on bottom, so I subtract 2. So it's going to be negative 5 minus 7 is negative 7. Minus 2 is negative 7. So b is to the power of negative 7. All right, so the 4, 3, and a all maintain their position on the top. And then the b goes to the bottom and the 7 goes positive. So that becomes 4 times 3 times a to the 3rd, and then b to the 7th on bottom. Now 4 times 3 has to be multiplied out, and that's 12. 12 times a to the 3rd over b to the 7th. Now the last problem we do a little bit differently because we have a subtraction operator. I do the 1, 2 process, okay? So I get rid of the exponent and make it duplicate the parentheses, okay? Because the second power is just whatever the base is times itself, and the base is the entire expression. And now I FOIL, okay? So 4x multiplied by 4x, 4x multiplied by negative 2, negative 2 multiplied by 4x, and negative 2 multiplied by negative 2. Okay, 4 times 4 is 16, and then x to the second, because it's x times x, and then negative 8x, and then negative 8x again, and then positive 4. So I go blank x to the second plus blank x plus blank. So x second, I got 16. X, I need to add the negative 8, so that's negative 16, and then 4. Okay. Now we start solving equations, okay? Now, unless I tell you it can't be factored, you're going to factor this. We have 2x to the 5th power minus 56x to the 3rd power plus 150x. So there's 5 solutions I'm looking for because we got x to the 5th power. Because we have x to the 5th, x to the 3rd, x to the 1st. So all these different powers of x mean I need to factor. So I start off my factoring like I normally do with 3 terms. There's 3, so I make a GCF box. I'll put GCF under it. And then I make my T-chart. Now, because we have a power higher than 2, and there's more than 2 solutions, we're going to have to check for more dots when I get down to the end in my T box. Okay, more dots. So that's 4 parentheses. That's the most you'll have, plus, minus, plus, minus. Now, we might cross some or all of them out, but at least they're there. So GCF, we don't have a negative in front. We have x to the 5th, x to the 3rd, and x. So I just do the x. 256 and 150. Okay, so I dial up my GCF calculator. Okay, and there we are. Some of you, if you already know it, you can put it 2, 56, 150. Okay, I got a GCF of 2. So 2x is the GCF. So 2x goes here. I put a parentheses around it, then I go divide all of these by 2x. Now, if you're dividing by an x, you can cross out x's somewhere. Not here, because these are different powers. Not here. Here I can. Okay, then 2 divided by 2 is 1. X to the 5th goes down to x to the 4th minus 56 divided by 2 is 28. X third divided by x is x. And then 150 divided by 2 is 75. Okay, and now I'm ready for my t. So A, B, and C. So I take A times C, meaning I take 1 times positive 75. It's positive 75. So it's positive 75, so I'm looking for a sum of 28. It's negative, it's difference, but positive is a sum. So 1 and 75 is not it. 75 is not divisible by 2 because it's a decimal. Divide by 3, you get 25. So 3 and 25 is worth writing down. 3 plus 25 is 28, so it's that. Okay, now my 28 up there's a negative. Now we have a sum because of the positives. So if it's a sum, the signs have to be the same. Okay, sum same, difference different. Okay, now you got to pay attention to your A. Your A is 1, but it has an x to the fourth connected to it. So since A is 1, we just need one line of parentheses, 2 of them total. But it's x to the fourth, so we split it. X second, then minus 3, minus 25. Okay. Now, one thing you want to do is circle that 2x and put it down here. Okay, I should have done that from the get-go. Okay, now do we have more dots here? Well, you have a minus here, but 3 is not a perfect square. So I circle that, cross these two out, and I write x to the second power minus 3 alongside the 2x. Okay, now the other one you have a minus, and 5 times 5, and x times x. Okay, so it's going to be x, 5, and I just drop those two parentheses around with everything else. If you want to put equals 0 behind it, that's fine. Okay, so I factored it out. I've done the hard work. Now I just need to set each factor equal to 0. So 2 times x could equal 0. I divide by 2, and I get 0. That's your first answer. Now I also have x to the second power minus 3. We add 3. X to the second equals 3. Now I will allow you to square root 3 on your calculator. Remember, it could be positive or negative, though, when you do a square root. You can write 1.73 and negative 1.73. I'll allow that. I'll also allow you to try to break it down, but you can't divide 3 by anything, so you keep 3 in its square root. So you can either go 1.73 or negative 1.73, or you could go square root of 3 and square root of 3 with a negative. Don't forget, if you have a negative square root number, you got to put the I in your solution. Okay, either one. Okay, go with the one you like better. Okay, and then x plus 5 could equal 0. X minus 5 could equal 0. These are easy. I just minus 5. I get negative 5. Then I add 5 and add 5. I get positive 5. Okay, and those are my solutions. Okay, now the next problem, I have x to the power of 3, so there's 3 solutions, and I have an x to the first with it, so that makes 2 terms I need to factor. So GCF. And then with 2 terms, instead of doing the t, we just look for a difference of perfect squares. Now again, when it's to the second power, that's where I know I'll be able to stop. But with more than 2 answers, we're going to want to look for more dots. Okay, so the GCF, we don't have a negative front. We do have x on everything. So x third and x means I take the x, and then 2 and 72. 2, 72. I got 2 again. So 2x. Now we'll parenthesize the 2x. Now, you're going to want to put the 2x. You don't just forget about it. You want to put that down there. And then I divide by 2x, divide by 2x. Remember, when you're dividing by x, you should be able to cross out somewhere. 2 divided by 2 is 1. X third divided by x goes to the second, minus 36. Okay, now dots. Well, you got a minus. 36 is 6 times 6. X to the second is x times x, and then 1 is 1 times 1. Okay, so that works out. I can put 1x, or xx if it's 1, then 6 and 6. Okay, now if we got a plus sign, we just circle it automatically, cross 2 of them out, and put 1x plus 6. We have a minus, we got to look further, but 6 is not a number you can write as anything times itself, so that's gone. And I circle it. So 1x minus 6 equals 0. Okay, so those are my factors. So 2 times x could equal 0. I just divide out 2, and I get 0. 1x plus 6 could equal 0. I minus 6. Minus 6, I get negative 6. You don't need to divide by 1. The other one's just going to be positive 6. I didn't have to do any square roots because there were no second powers left over. Okay, next problem. X to the third, there's 3 solutions to the equation. And again, we got x third, x second, and x to the first. So we're going to have to draw some boxes. Now, there are 4 terms here. So what I do is I go make my big grouping box. Factor by grouping. I don't even worry about GCF when there's 4. So parentheses plus parentheses, line parentheses plus line parentheses, line parentheses. And then since there are more than 2 solutions, we're going to have to check for more dots. Okay, so I've dropped down 1x to the third plus 5x to the second, and then negative 9x minus 45. Then we're looking for the GCFs 2 at a time. Now, we don't have a negative in front, so no negative here. We do have a negative here, so that we need those negative. Okay, now x's, x third and x second. Okay, we take x to the second, because that's the smaller of the 2 powers. We don't have x on 45, so we don't want to put an x down there. 1 and 5, the GCF's 1. You can put 1 if you want. Okay, I'm just going to leave it, though. Okay, 9 and 45, though, is going to be something completely different. So 9 comma 45 gives me 9 as the GCF. Okay, so x to the second's factored out, negative 9's factored out, and that gives me 1x plus 5. Remember, these cross out. And this will be the same thing, 1x plus 5. So I have 1x plus 5 in each parentheses. And that leaves me with x to the second and negative 9, so I write 9 with a minus. Okay, so dots. Let's look at these 2 at the end. I have a plus here, so I circle it, cross it out, and then 1x plus 5 moves out here. Okay, minus 3 times 3, x times x, so you bet that's a dots. X, 3, 3. Then I circle those factors. So x plus 3, x minus 3. Okay, now we set all those equal to 0. They're all going to be easy to solve because I don't have any second powers left. It's when you have the second powers it gets annoying because there's 2 answers, the positive and the negative. You get the I you have to worry about. But I did help you out by letting you square root it on your calculator even though it's not a perfect square up on the board. So I subtract 5, I get negative 5 for my first answer. I subtract 3, I get negative 3 for my second answer. And the other one's positive 3. Okay, there's your solution set. Okay, now the next one says solve the equation, but I wrote it's not going to factor. Okay, so there's 4 terms, but grouping's not going to work. Okay, it's going to lead to all kinds of problems. So if I put it will not factor, you need to make your synthetic division L. And on the inside, you're going to have positive 1. Now, don't put the variables. Negative 4, negative 15, and 18. Now, to find the outside number, which is our first solution, we just trial and error. Go 1, 2, 3. If that doesn't work, negative 1, negative 2, negative 3. So we're going to go 1. So 1 parentheses 1 to the power of 3 minus 4 parentheses 1 to the second power minus 15 parentheses 1 plus 18. Okay, I got 0 luckily, so I have my outside, and that's also my first solution. So I drop my 1. 1 times 1 is 1. Then I add. Negative 4 plus 1 is negative 3. Negative 3 times 1 is negative 3. Then I add. Negative 15 plus negative 3 is negative 18. Negative 18 times 1 is negative 18. We add there, and that comes to 0. You're always adding. Okay, now what we've done is the 1 now is no longer an x to the third, it's an x second, minus 3x minus 18 is 0. Okay, so 3 terms. Your GCF normally doesn't work, but that's what we're used to doing with those. And you're like, well, what about more dots? I don't need it. I only have 2 answers to find. Okay. So GCF, negative in front, nope. X on, and you're doing it from here. X on everything, not on 18. 1, 3, and 18. It's just a 1 GCF, so I don't do it. ABC. So I take A times C. So 1 times negative 18 is 18 negative. So I got a negative, so I'm looking for a difference. That would make 3. 1 and 18, that's 17. 2 and 9, that's not 3. 3 and 6, that's 3. That's 3. Okay, now the 3 in the middle is negative, so you know you got negative 6. And it's a difference because of the negatives, so the signs have to be the opposite. So the opposite of negative is positive. Okay, A is 1, okay, and it's x to the second. So that's good. I can just make 1 line of parentheses, and x to the second means I can just put x with no exponent. Plus 3 minus 6, okay. So you F1, F2 those, each one of those factors could equal 0. Subtract 3, get negative 3 as your second solution, plus 6, positive 6 for your third. That's your solution set. Okay, now you got a couple story problems. For 1998 to 2005, the sales of sporting goods can be modeled by this equation here. So I'm going to write it out. 0.0071. Put a capital T so you don't think it's a plus. Plus 0.1 capital T to the second. Plus 1.4 capital T. And don't forget we have a constant of 70. Okay, T represents the number of years since 1998. F represents the sales in billions. Calculate the sales in the year 2005. Now, anytime they give us an equation, we need to identify what the variables mean. S and T. So S is sales. It's told us that. And T is T represents the years, but it's since 1998. Now, sales would be dollars, but they don't give me any dollars amount, so I'm not going to put anything in for S. That's going to stay the way it is. Now, T is years. Give me a year. Don't use 1998. That's your first year. So later on in the problem, 1998 again, 2005, okay? So 2005 is going to go in for T, but we need to subtract 1998. And that gives me 7. So I'm going to insert 7 in for the T, okay? And I'll find what S equals if I just insert that. So 0.0071 parentheses 7 to the third plus 0.1 parentheses 7 to the second plus 1.4 parentheses 7 plus 70. Okay, I got 87.13. Now, sales would be a dollar sign, and it says in billions, you just put billion. Just write the word. Okay, then number 8. One of the costs to print a novel can be modeled by the equation C equals x to the third power minus 10x to the second plus 28x. X represents the numbers of novels printed by the 1,000, and C is the cost in thousands. So I want to write that equation that they gave me. I don't need to come up with the equation in this standard. The company now prints 5,000 novels at a cost of $15,000. What other number of novels would cost the same amount? So we need to know what these represent, C and X. Okay, C is the cost. You can just put dollar sign. That's in thousands, keep in mind. And X is the number of novels, whatever the product is they're selling. Okay. Now, do they give me a money amount for C? Yeah, they do. They give me 5,000. but I can just use 5 because it's in thousands. It says it is, okay? So we're going to replace C with 5. Now, novels. Am I given a novels number? Or no, my bad. I screwed that up. C is money. They give me 15,000, but I can just use 15, so it's 15. And then X is novels. So they give me 5,000 novels. But since it says, since those phrases in thousands are there, I can just put 5 in for X. Okay, so we're going to replace all the X's in with 5. Okay, now I'm going to plug this in, just make sure it equals 15. So parentheses 5 to the third minus 10 parentheses 5 to the second plus 28 parentheses 5. And I got 15, just like I should. Now, the key is I want the cost to stay at 15, but I want to find other x's that would also give me 15, be equal to 15. So there's 3 solutions to this, and we already have one of them. I just had 5 in, okay? So to find my other answers, I'm going to use the synthetic division. I know I can divide by 5, but one thing, you need to move that 15 to the other side so you have a 0 then on that side. You can use synthetic division, you got to have 0. So you got 1, negative 10, positive 28, negative 15. So I drop the 1. 1 times 5 is 5. Then I add negative 5. Negative 5 times 5 is negative 25. Then you're at 3. 3 times 5 is 15. Good. Now remember what that accomplishes. It takes it to x to the second. X equals 0. Okay, 3 terms. So GCF and T. Okay, GCF is just going to be 1. You don't have the negative, you don't have the x on everything, and 1, whenever 1's one of the numbers, that's a giveaway that it's 1. Okay, now A, B, and C. A times C. 1 times 3, that's 3. Positive sum of 5. Now, 1 and 3 is a sum of 4. That's the only thing, so that's a fail, and that gives me the go-ahead to use my quadratic formula. So the opposite of B is 5, plus or minus the square root, parentheses the second, minus these 3 parentheses. So B is negative 5, and then 4, A is 1, C is 3. And on bottom you got 2 times 1, which is 2. Now I punch in the square root. I should not be getting a domain error on a story problem, okay? Minus 4, 1, and 3. So I do the square root. Okay, I did not get a domain error. I got 3.6. So I cross that out, just put a little 3.6 there, and there's no I, so I can keep doing my math. 5 plus 3.6 divided by 2, I got 4.3. Okay, and then 5 minus 3.6 equals, divided by 2, 0.7. Okay, all those are legit answers, okay? Because remember, these are in thousands, so it's 5,000, 4.3 thousand, which is 4,300, and then 0.7 thousand is 700.